All right, welcome and thanks for joining for just this optional video. I'll try and make it relatively short. So we just got 4 slides to go through. First one, writing recursive formula. Make sure you pause if you need to go find this slide. We're going to write the next 4 terms of the sequence. So we have a sub k plus 1, meaning the next term is equal to the current term minus 4, given that the first term of our sequence is 25. So here we're working with something that's recursive. You can always tell by that k. And then the k plus 1. Those are things that don't show up in something that's explicit. So we know our first term is 25. And what this is really just saying to us, in layman's terms, is you find the next term by subtracting 4. So if I start at 25 and then subtract 4, I get 21. And then subtract 4, I get 17. And then subtract 4, I get 13. And then subtract 4, I get 9. I'll stop there because it asks for just the next 4 terms in the sequence. Now, it also says find a formula for the nth term of the sequence. So formula for the nth term means that we're looking for something that's explicit. So an explicit formula is being asked here. Our formula for that is a sub n is equal to n times d plus a sub 0, where d represents the thing that I'm adding over and over and over again. In this case, that thing is negative 4. A sub 0 represents not the first term, but the term that would come before it. So if I'm starting at 25 and subtracting 4 each time, then the term before this would have been 29. For my formula, then I just have a sub n is equal to d, which is negative 4, times n plus 29. All right, great. We're going to skip this slide. You're going to skip your slide. I already got rid of it. Now we're going to move on to this next one. Find the following sums. So here we're using the formula, the sum based n is equal to n divided by 2 times a sub 1 plus a sub n. So we're sort of applying this formula now. First thing that you want to do is verify that the sequence is arithmetic. And the reason you want to do that is because in 8.3, we're going to be looking at things that are geometric. So you want to make sure that this is the formula that you should be using. Then use the formula. So in this first case, if I'm looking at this 4, 4, 4, 4, 4. So yeah, this is arithmetic. Great, first step done. Now I'm just going to use the sum formula. The sum formula says the sum of the first n terms. So looking at this, I have here 1, 2, 3, 4, 5, 6 terms. So n is equal to 6. A sub 1 is equal to the first term, which is 1. A sub n is equal to just the last term in the sequence. So in this case, the last term is 21. A sub 6 in this case, it's the 6th term, is 21. So for our sum formula, we got everything we need now. We have s sub 6 is equal to 6 over 2 times 1 plus 21. This is 3 times 22, so 66. It's s sub 6 because we're saying the sum of the first 6 terms of this sequence. That's it. Easy breezy. All right, for this next one, I see here I'm adding 3, and it just continues on. That's what this is telling us. We're going to keep doing this infinitely until we get to 39. It's sort of going to be important here. So we need 3 things. N is equal to a sub 1 is equal to, and this is usually pretty easy. A sub 1 here is 3. It's the first term. And a sub, we want the last term. So the thing we have to be thinking through is like, this sequence ended at 39, but some number of things happened in between here. So when you're looking at the fact that, okay, I'm adding 3 each time, what you want to keep in mind is I started at 3 and I kept adding 3. So a sort of quick thing I could do for this one is just 39 divided by 3 to give me this term number. Not always exactly the case, but I'm going to get here a term number of saying that there are 13 terms. And then that's going to mean that a sub 13 is equal to 39, the last term in the sequence. We already knew this was the last term. Like I could have filled this in, but I just didn't know what that number was yet. So now I'm going to have the sum of the first 13 terms is equal to 13 over 2 times the first term is 3, the last term is 39. When I add those together, I get 42 times 13 over 2. This is a non-calculator quiz. So, maybe just practice. 42 over 2 is 21. So I'm doing 21 times 13. 3 times 1 is 3. 3 times 2 is 6. 0. 1 times 1 is 1. 1 times 2 is 2. Add 3, 7, 2. So our sum here is 273. All right, and then last, we have it using sigma notation. So using sigma notation, this does get sort of cooler. These are usually the ones that are a little bit tougher. So again, we want 3 things: n, a sub 1, and a sub whatever that last term is. What n represents is the number of terms. This sigma notation tells me I'm starting at 1 and ending at 20. Between 20 and 1, there are 20 terms there. So this is going to be 20. Be careful about a time in which this index, this lower limit, is something that's not 1. Those are the times where people are more often to make mistakes. And we'll see that in a lot of examples. But just know those are the ones that you just have to do a quick extra thinking. All right, a sub 1. A sub 1 means the first term. So I'm substituting 1 into this. So I have a sub 1 is equal to, I don't know why I put that 2 in parentheses, 2 times, I'm replacing I with 1. Minus 1, so this gives me 1. A sub 20, because I'm looking for the 20th term, means I'm substituting 20 in here. So 2 times 20 minus 1 is 39. Sum formula of 20 terms is equal to 20 over 2 times 1 plus 39. 20 over 2 is 10 times 40, so this is equal to 400. All right, great. Next 2 slides, last 2 slides that we're going to be doing. Find the 15th partial sum of the following sequence. So notice this sequence is an infinite sequence, but I'm only looking for the sum of the first 15 terms. So that tells me right away, n is going to be 15 here, looking for 15 terms. So I'll have s sub 15 is equal to 15 over 2 times the first term is 10. This last term is the thing I need. That last term is the 15th term, which I wrote that very small, sorry. Let's just leave a little bit more space. This is the 15th term in the sequence that goes here. So what we can do is use our ability to write explicit formulas. So we know that there's a formula for explicit sequences. For explicit arithmetic sequence of a sub n is equal to n times d plus a sub 0. And I could use this and say, okay, well, n, the term number I'm looking for, is the 15th term. D, the common thing that's being added here, is 5. A sub 0, if I were to have a term prior to this, that would be a sub 0, and that would be 5. That means that the 15th term of this sequence is 80. So we'll have s sub 15 is equal to 15 over 2 times 90. You can cross-reduce this. 90 over 2 is 45. So we're doing 15 times 45. 5 times 5 is 5, 2, so 25. 5 times 1 is 5, plus 2 is 7, 0. 4 times 5 is 20, so 0, 2. 4 times 1 is 4, plus 2 is 6. So this is going to be 675 for a final answer. Generally, these aren't too bad, especially right now when all you know is the arithmetic sum formula. When we do the geometric one, it's not really that bad either. It's just a matter of remembering first to check arithmetic or geometric, and then the geometric form is just a little bit weirder. Find the 12th partial sum of the following sequence. So same mentality here. What I realize is I'm adding 3 each time, so it is arithmetic. I'm looking for the 12th partial sum, So that means that I'm adding the first 12 terms. So we'll have S sub 12. The sum of the first 12 terms is equal to 12 over 2 times the first term, 2, plus, and what's going to go right here is the 12th term. Now, I know you're thinking like, okay, I could just keep adding 3 and get to 12th term, Mr. Davis. So why do I have to actually do that explicit formula? Well, because I want to know that you could do it even if it was like the 100 billionth term, or 100,647,532,147th term. So we're going to have a sub n is equal to n times d plus a sub 0. N here is 12. D, the common difference, I'm adding 3 each time. And a sub 0, the term that would have come before this is negative 1. Whatever, I just wrote plus negative. It's not a final answer, so I'm not going to care about that. 12 times 3 is 36, minus 1 is 35. So here I'll have a 35. 2 times 35 is 37. 12 over 2 is 6. 6 times 37, 2, 4, 6 times 3, so 222. Awesome. Look, no calculator, 4 slides. Hopefully it didn't take too long. Make sure that you guys, look this over, make sure that if you have any questions that you do ask them. Otherwise, just be prepared to start on that homework.